Hello, my name is Varun Surya. In this video, we're gonna cover topic called graph mining. What do graph mining means? Graph mining means extracting useful patterns, knowledge, or insight from the graph. What are the applications of graph mining? Applications of graph mining are social network analysis, fraud detection, drug discovery, recommendation system, and web search and ranking. These are the applications of graph mining. And why do we need graph mining? In traditional data mining, relationship between data points are not directly considered, but in real world applications, connection matters. Graph mining allows us to do frequent subgraph mining, node classification, link prediction, and community detection, and short path algorithm. In this video, we gonna cover frequent subgraph mining, node classification, and link protection in detail. And we'll go with the frequent subgraph mining. Frequent subgraph mining is a task of identifying subgraphs. Like what is subgraph? When we see this is called supergraph, like it is a full graph, and a part of this graph is called subgraph. Like mining the frequent subgraphs is called frequent subgraph mining. These subgraphs often represent common structures or patterns that are useful for classification and predicting prediction and or anomaly detection. Let us solve a problem in Let us solve a problem using the span algorithm. Let us consider this data set, graph data set, where we have three graphs and the frequent subgraphs are 10 node 11 to 11 subgraph and 10 to 11 with 20 weight subgraph. When we see 10, it occurs here, it occurs here, it is occurring here, here, and here also. So it is occurring five times in the data set, and the minimum support is three. So we can say that it's a frequent subgraph, but it does not work like that. The minimum support three means it should occur in the three graphs. Like 10 should occur in every graph. So it is occurring here, here, here. We don't consider that it is occurring five times in a graph. It should occur in every graph. That is what G-span algorithm says. So when we consider 11, it is occurring here, it is occurring here, and it is occurring here also. Let me erase this. And similarly, the subgraph, this subgraph is occurring in this, and this also occurring in this graph, and it is occurring in this graph. So it satisfies the minimum support rule. Hence, it is also called as frequent subgraph. Now let's go to the topic called node classification. Node classification in graph mining is a graph mining task where we predict the labels of node based on the attribute and connections. Let us understand how it works. Like for example, we consider this graph. We consider this graph like A was labeled as red and D was labeled as blue, and B is not at all not labeled, and C is labeled as red. And we seen here based on the attributes and the connections. Like B was having connections with A and C and does not have any connection with D. So and the attributes of A are red and attribute of C is red. So B definitely gonna have the value and will be labeled as red. And in node classification, we're gonna see small code snippet. Here is a small code snippet for node detection. Sorry, sorry. Okay, here is a small code snippet for node classification. Node classification. Cut. Here is a small code snippet for node classification. Uh, in step one, we're gonna create a graph and we're gonna add nodes for that graph. We're gonna add nodes for that graph, and we also add edges for that graph in step two. And we will extract the futures. Like extracting future means extracting degrees for a specific label. Like how many neighbor nodes are there for 4, 5, 6, and 1, 2, 3, 4, 5, 6 up to 10. And we're gonna extract that. And uh, and in X array we're gonna put values of like we're gonna put degrees, and in Y array we will put values of labels, and we will split the data and we will train the logistic regression model, and based on that we will do the predictions. And let us run this code and see what will be the output. So we can see we labeled first node as 1 and second node as green and third node as blue, and based on uh, logistic regression, it predicted remaining all nodes as blue. Okay, let us solve a problem on this by taking this graph. Let us find the value. How? Let us find the value how 4 is labeled as blue. When we see 4 has 3 edges, like it is having 3 connections. So degree of 4 will be 3. Please remember that we're going to use that in this problem. In logistic regression, first we'll calculate scores of the labels. And the formula for score is Z is equal to W into X plus B, where W is the weight and X is the degree for a specific node, and B is the bias. And let us assume weight of red is 0.8 and bias is minus 1.5, and weight of green is 1.2, bias is minus 2.0, and weight of blue is 0.9 and bias is minus 1.0. And when we substitute that in this score formula, we will get scores of red, blue, and green. And next step is converting it into probabilities. And the formula for converting it into probabilities is this. And and for that we need to find e power of this course, and e power of 0.9 is 2.46, and e power 1.9 is 4.95, e power 1.7 is 4.7, 4.7, like almost similar, like close to these values. So, and next step is calculating the probability. The probability of red is this value by all values, like 2.46 by 4.46 plus 4.95 plus 5.75, which is close to 0.19. Similarly, we should do the same calculation for the green and blue. And after finding the values, we have to see which has the biggest value. The blue is having the biggest value as compared to red and green. So the value of the fourth node will be blue. This so the fourth node is blue. This is how the calculation is done and labels are assigned to the node. Our next topic is link prediction. Link prediction is a fundamental task in graph mining where the goal is to predict a link between two nodes should or will exist in the future on current network structure. A common approach to do is link prediction is Jaccard coefficient, and the formula for Jaccard coefficient is ratio of common neighbors to the total neighbors. That is given here modulo of A intersection B by modulo of A union B. Let's solve an example using Jaccard coefficient given four nodes and with these edges, and we had drawn this graph based on these edges, and we have to predict predict the link might form between node 4 and node 5 using Jaccard coefficient. First step, we have to find the neighbors of the all nodes. Uh, for node 1, neighbors are 2 and 3. For node 2, neighbors are 4, 1 and 3, and neighbors of node 3 is 5, 1 and 2, and neighbors of 4 is 2, and neighbors of 5 is 3. And then in the next step, we have to calculate Jaccard coefficient for node 4 and 5. The neighbor nodes of are 2 and neighbor nodes of 5 is 3, as we found the last step. The common, and there are no common neighbors, so it will be 0. And the union of the neighbors is 2 and 3, so there are two values, so it will be 2. 0 by 2 is equal to 0, as so there is no similarity between node 4 and 5. There will be no link formed in future based on the current connections. This is it for the video, and thank you.